Hi, it's Mrs. Schnee, and I am here with you for lesson 6 on histograms, so something new for today. And I got a picture of my dog Glynis to join us today because the first part of the video is about a dog show, and I always like to have something different for you guys to look at during the video. All right, so it says here's a dot plot, and it shows the weights in pounds of 40 dogs at a dog show. It says write 2 statistical questions that can be answered using the dot plot. So I thought of a couple. One, I said, how many dogs weigh more than 100 pounds? So that would be a statistical question that you could answer based on this dot plot. So some of the dogs weigh more than 100 pounds on this side, and some weigh less, and some weigh exactly 100 pounds. It would take some information to look through and find that answer. Here's another one. What is the difference between the lightest and heaviest dog? And then with that information, you could find from the lightest to the heaviest dog what the difference would be. So I'm sure that if you were to think through, you could find a lot of different questions that would be statistical. Remember, in order for it to be a statistical question, there needs to be some variability. And there also needs to be some kind of work that's being done instead of just what was the weight of Glynis. If you wanted to find that, that wouldn't be a statistical question because Glynis is just one dog, but and her weight would just be her weight. It wouldn't have any variability. So it doesn't really take much work to ask that question, so it's not a statistical question. All right, now what would you consider a typical weight for a dog at this dog show? So when I thought through this question, I was thinking back to typical, meaning sometimes the center or the middle part of the information, especially if it's spread out pretty evenly. So when we're thinking about that, I'm seeing, it seems like it'd be somewhere in between, like if we go from here to here, somewhere in between 100 and 110, somewhere in that range. So I would say that the typical weight would be somewhere between 100 to 110 pounds. Okay, would be kind of a typical weight. So that is where we're at for that warm-up part. Let's move on to dog show part 2. And oh, I forgot to mention, at the end of the video, we'll have the cool down part. So I'll just scoot that over to the side for you. All right, so here's a histogram that shows some dog weights in pounds. And we haven't used histograms yet. What they kind of look like is bar graphs, but there's a little bit of a difference in between what a histogram and a bar graph is, and we'll work with that today. You do see an x-axis and a y-axis. You might also notice that there's kind of a label here. There's numbers going from 60 to 80 here, from 80 to 100, from 100 to 120. So you can see that the incrementally the same amount here. And on the y-axis, we're going up by 2, 0 to 2, 2 to 4, 4 to 6, going up by 2 in that way. It says each bar includes the left end value, but not the right end value. For example, the first bar includes dogs that weigh 60 pounds and 68 pounds, but not 80 pounds. So this 80 pound, like if there was a dog that weighed 80 pounds, it would be indicated in this part of the bar graph. We're going to use this histogram to answer the following questions. It says, how many dogs weigh at least 100 pounds? So if we're looking at that, we're not going to use this information, that's not 100 pounds, not this information, but we're looking at this part of the chart, this part of the chart, this one, and this one. So everything that's 100 or more, since we're saying at least 100 pounds, would be indicated there. So if I look at this one, it looks like 14, and on here, let's say 5, and here we're looking at 3, and here we're looking at about 1. And I can double check that by looking at my histogram and comparing it to my dot plot. If you can see here, that information is here. So you can see this dog is indicated here because he's between 160 and 180 pounds. So if you can notice, that's where we're looking at for this information. So if I were to find out how many dogs weigh at least 100 pounds, I could count all of these dogs and add them all up. So I can do that. 19, 20, 23 dogs is what I'm noticing. 23 dogs weigh at least 100 pounds. For B, it says how many dogs weigh exactly 70 pounds? Well, if I look here, am I going to be able to find out how many dogs weigh exactly 70 pounds from this histogram? No, I can't. I can only know that there might be some in that range, but I'm going to say unknown for this answer when I'm looking at the histogram. For C, it says how many dogs weigh at least 120 and less than 160. So now we're looking in between 120 and 160, somewhere in that range. And we're going to find that that's 5 and 3. I can add those together. That would be 8 dogs. How much does the heaviest dog at the show weigh? Well, if I look at this histogram, I know that it's somewhere in this category, but it doesn't tell me exactly what that dog weighs when I'm looking just at the histogram. So I'm going to have to say that that's another unknown, but I know that it's somewhere in between 160 to 180 pounds, 160, 180 pounds, but I don't know exactly compared to this. Now, when I'm looking at the part where it says, what would you consider a typical weight for a dog at this dog show? This is what histograms are fun to use for, because when we're looking at the dot plot, it's got a big range of all the dots all throughout. And remember, this is the same information. But then when you use a histogram, you can see that the center is a little bit easier to pick out, that typical range. And also in this case, the center value is, or close to the center value, is the most frequent value as well. So I could say that somewhere in between 100 to 120 pounds would be a typical weight. So I can say typical would be 100 to 120 pounds because it's the most frequent, and also it is kind of in the center of this curve here, okay? So we're gonna skip the part that says discuss with a partner. If you would like to, you can look at the information and pause the video, but it's asking you to use the dot plot to answer the same questions and see what you would use to help you with answering that. But we're going to go ahead and go on to another part, which is the population of states. I had to say goodbye to Glynis. And we're looking at population. And this is interesting because it says every 10 years, the United States conducts a census, which is an effort to count the entire population. The dot plot here shows the population data from the 2010 census. Well, when it says 10 years, and this is from 10 years ago, it's kind of interesting. We're going to be having a new census that they're taking in 2020. So you can find that information out, and you might see signs for it as we go, but we're approaching that. And it says this is for each of the 50 states, so all 50 states plus the District of Columbia. Now, when you look at this dot plot, you can see some distinct dots, but then you see a bunch of jumbled up dots here, okay? And even if I go really close in the video to see, it's not the video quality, it's just some of them are more dot-like and some of them are more blob-like, okay? So it says here are some statistical questions about the population of the 50 states and DC. How difficult would it be to answer the questions using the dot plot? So we're going to do this one first, and then later on we're going to transfer the information into a histogram and then come back to it and see if it's any easier to answer. Now, you know from my class that easy is a word that I try not to use too much, but for this sake of the purpose of the video, we're definitely going to use that word easy to see what makes it easier to understand the information from a dot plot to a histogram. All right, let's start. It says, how many states have populations greater than 15 million? Okay, so if I look here, I'm seeing 15 million's about right here. I don't have to answer it. I'm just trying to see, is it easy to answer, hard to answer, or impossible to answer for this? Well, I could count that up. I could say 1, 2, 3, 4. So that is something that would be easy to answer using a dot plot. Going on, it says, which states have populations greater than 15 million? Well, they don't tell me what state this is. This could be Alaska, Hawaii, New York. I don't know what these dots are meaning, so that would be an impossible question to answer here because we don't know what state that is. How many states have populations less than 5 million? Okay, so 5 million would be about here. This is where it's all jumbled up and there's not really distinct dots. So that's going to be another situation where it's impossible for me to use this dot plot to answer that question, even though it's a statistical question. For D, what is the typical state population? Well, when I'm looking at that, I could possibly do some looking at what the middle part is, then I could kind of look at what that typical center stuff or center value would be, but that's going to be actually pretty hard to determine based on that dot plot. It wouldn't be very easy. E says, are there more states with fewer than 5 million? So kind of if we look at 5 million here, fewer than 5 million people, or more states with between 5 and 10 million. So if we're saying 5 and 10 million, we're comparing this range of information to this range of information. That would be very hard to tell from this dot plot. For F, it says, how would you describe the distribution of state populations? Describing the distribution is going to be another challenge because we have some states that are pretty low in comparison to states that are very high, but there's a big range. There's a very large range, so that's going to be a hard question. Okay, like I said, we're going to come back to this after we use our histogram. So I'll scoot that over. Now, here is the actual population data. So I'm going to pull this down a little bit. They give us all the states, all 50 states, plus the District of Columbia, and they give us in terms of like 4.78 million people in that state. So what I did ahead of time, so you didn't have to watch me do it, is I went through the chart and I put the values in. So for instance, 4.78 million would be a red, that Alabama would be included here. And I just counted up all the states that had to do with from 0 to 5 million. Then I counted up all the states that had between 5 and 10 million, and so on and so forth. So I kind of color coded it to see the values there. Interestingly, there's a couple that had no values, but there was quite a disparity. Okay, there's quite a range there. So I'm going to use that information and I'm going to create my histogram from that, okay? So just like that dog show one. Now, when I'm looking from 0 to 5, I'm seeing 0 to 5 here. It relates to that. And I want to go all the way up to 29. So I'm going to go up here past 28 to 29 and make a heavy bar there, okay? Next, I'm going to go from 5 to 10. So from 5 to 10, there were 15. So I'm going to come up to 15, make my heavy bar there so that I can come back and make those bars. Now from 10 to 15, I had 3, so I'll come up to 3 here. From 15 to 20, I had 2 states. From 20 to 25, there were none, so I'm going to leave that blank. From 25 to 30, there was just 1 state that was in between that range. And from 30 to 35, nothing. 35 to 40, only 1 state. Okay, so now that I've made like the top part of my bar, I'm going to go back through and I'm going to make and finish up these bars. So histograms and bar graphs are close to the same, you'll just notice that when we did our bar graph, we didn't have a range of values. It would just be like only one value here, so 0 or 1 or 2, but from here to here there's 5 values. Kind of the difference between a bar graph and a histogram. Okay, so now I've just transferred this information, the frequency of the states, populations, to this grid. So now I will put that over to the side. And just to kind of help you and remember, what we started with was this dot plot of all these values. So it does look a little bit different, and you can kind of see the heaviness over here of these dots, and you can see now there are 29 states in this category, and that's why we couldn't really see all the dots in the same spot. Okay. All right, so it says return to the statistical questions at the beginning of the activity. Which ones are now easier to answer? So bringing that back, we're looking at how many states have populations greater than 15 million. So here we are again, 15 million. Now it's a lot easier. I can see there's 1, 2, 3, 4. I can actually see that, and it's still an easy thing to find out. Which states have populations greater than 15 million? Well, when we're looking at that, we're seeing which are the states. Well, I can still see that there are states, but I don't know which states they are. So I have no idea if this is Arizona or if this is Connecticut. I don't know. So that's going to be another impossible one to answer. How many states have populations less than 5 million? Now, less than 5 would be this category. So it went from a question that was impossible to answer to now something that's pretty easy to see on this histogram. What is a typical state population? So before we had a hard time finding that. With this one, it is a little bit hard still because we don't have a curve. We have something very heavy on this side that's going around. We'd have to do a little bit more information, some digging to find out what the typical population would be. With E, it says, are there more states with fewer than 5 million or between 5 and 10 million? So fewer than 5 million would be in this category, and between 5 and 10 is in this category. So now I'm able to see that there is a difference there that I can find pretty easily compared to how it was on the dot plot. For the last question, it says, how would you describe the distribution of state populations? So in that situation, I could say, wow, there's so many that are between 0 to 10 million and very few that are up here. I could talk about that distribution and how that's worked. So it would be a little bit easier to determine how that curve is happening and where most of the state's population is doing. So there's quite a difference between this dot plot and this histogram. And depending on what information you have and what you are trying to do with that information, you might want to use a dot plot or you might want to use a histogram, just depending on that data. Okay, so let's go on. It says for the Are You Ready for More part, it talks about the 2 of the statistical questions that can be answered using the data and deciding whether the question can be answered using the dot plot, the histogram, or both. I'm going to have you skip that part unless you really want to do it. Okay? So we're going to move on to summary. Again, today the idea was learning what a histogram is and also knowing why you would use it and how it's different from a bar graph. And I highlighted some information here. It says in a histogram, data values are placed in groups or bins. So again, there's this dog weights dot plot, and then we've got this histogram. And it's nice because they've got these values and they kind of funnel into one category instead of having to count up all the dots. It's just another way to see it, especially when you're looking at the dot plot when it has multiple values, like those 50 states plus DC. It was really hard to see. I mean, not one state had the exact same population, so they were all kind of jumbled in there and fuzzy. But with the bins or the groups, you can see that information a little bit clearer. Okay? Now is the time in our video that you're going to pause and work on your histogram cool down, lesson 6 cool down. It's about rain in Miami, and then come back to the video and check your answers with me. All right, so we're back and it is the cool down rain in Miami. What I have done is I have looked at all the average amounts of rainfall in inches, and I've gone through and I've put them together in a frequency table. So from 0 to 2 inches, there was just 1 month that had that information. 5 months that had from 2 to 4 inches of rainfall, and you can see the rest here, 1, 5, 1, 2, and 3 for our frequency. And then I transferred that information over to our histograms. So between 0 and 2, there was just 1. So I came all the way up to 1 and I made my bar, okay? Next, from 2 to 4, I had 5. So I went all the way up to 5 and made my bar. From 4 to 6, I had just 1 month, so I made my bar there. From 6 to 8, I had 2, and there's what my bar looks like. And lastly, 8 to 10, I had 3 values or 3 months that worked with that. So I am seeing that. All right, now at the bottom it says, what is a typical amount of rainfall in 1 month in Miami? Well, that is still difficult to say. Even though we know the frequency, the distribution of the values and the data is not very, it doesn't flow in a typical curve. So you would have to do a little bit more research. You might have to find the average or something like that, and we haven't worked with that yet. So I said between 2 and 4 inches are in 5 of the months, but for the other parts of the year, it falls outside this range. So really, that 2 to 4 inches only happens for 5 months, and then the rest of it has some differences and discrepancies. So hopefully you didn't spend so long trying to figure out the typical amount, because it's really difficult to tell from this information. Okay? Great job today. There's histogram value. If you see a histogram in normal life situation, maybe in the news or somewhere in a textbook that you might have seen, maybe science, you can now find that histograms and bar graphs are a little different. And I hope you enjoyed the video, and I will answer any questions that you have. Just go ahead and email me. Okay, thanks.